Earlier today, I published a video about copyfail, a 9-year-old Linux kernel bug that gives any unprivileged user a root shell on every major Linux distribution, no race condition, no forensic trace, and it works every time, and there's already a new one out. Dirty Frag dropped this morning after a researcher was forced to release it early when someone broke the coordinated disclosure embargo. There are no patches for any distribution as of right now. No CVE has yet been assigned, and critically, if you applied the copyfail mitigation, it does nothing against this one. This is a breaking story, and I'm recording this within hours of disclosure, so here's what we know. Dirty Frag was discovered and reported by Hyunwoo Kim, the same researcher who found copyfail. It's a universal local privilege escalation where any unprivileged local user can get a root shell on all major Linux distributions. Like copyfail and Dirty Pipe before it, Dirty Frag exploits the Linux kernel's page cache. The page cache is the in-memory copy of files that the kernel maintains for performance reasons. The attacker gets the kernel itself to overwrite those in-memory file copies without ever needing write permission on the actual files. Where Dirty Frag differs from copyfail is the attack path. It chains two completely separate kernel vulnerabilities. The first is an XFRM ESP page cache write, which is a flaw in the IPsec ESP networking stack present since January of 2017. And the second is an RxRPC page cache write, which is a flaw in the RxRPC networking subsystem that's been present since June of 2023. The exploit tries the ESP path first, and if that's blocked, for example, Ubuntu sometimes blocks unprivileged user namespaces via AppArmor, which the ESP path needs, it automatically falls back to the RxRPC path. The two paths cover each other's blind spots. On essentially every major distribution, at least one of these two paths works. The result is no race condition, no kernel panic on failure, no per distribution offsets needed. It just works every time. So now let's talk about why the embargo was broken. The disclosure timeline here is worth understanding because it explains why there are no patches. Kim submitted the patch for the RxRPC vulnerability to the NetDev mailing list on April 29th. On May 7th, he submitted the full vulnerability details and exploit to the Linux distros mailing list, which is the standard coordinated disclosure channel for kernel vulnerabilities. The embargo was set for May 12th, giving distributions 5 days to prepare patches before public disclosure. But there was one condition in the agreement. If a third party published the exploit publicly during the embargo period, full disclosure would happen immediately. On May 7th, an unrelated third party published the ESP exploit publicly, breaking the embargo. Kim then consulted with the Linux distro maintainers, got agreement to proceed, and published the full Dirty Frag document. No distribution had time to prepare a patch, no CVE has been assigned, and the full exploit is public right now. Now, this is the most important thing that I need you to take away from this video. If you watched the copyfail video and applied the mitigation, that does absolutely nothing against Dirty Frag. The two vulnerabilities use completely different kernel subsystems. The copyfail mitigation blocks the ALGIF AEAD module. Dirty Frag doesn't use that module at all. And as a result of that, you need a separate mitigation for Dirty Frag. So what do we do now? The mitigation that we've currently got comes directly from the researcher's own GitHub repository. You're going to run the command that's on the screen, and I will try to have that also in the video description. This does two things. It creates a modprobe.d rule that prevents ESP4, ESP6, and RxRPC from loading in the future, and it immediately unloads these modules if they're currently loaded. The toDev null true at the end suppresses errors if a module isn't currently loaded, and that's expected and fine. You can verify that this worked by running the command that's now on screen. No output means the modules are not loaded and the mitigation is in place. Now, there is an important caveat here, and that is that ESP4 and ESP6 are the kernel modules used by IPsec VPN connections using ESP mode. If you run an IPsec VPN on this machine, unloading these modules will break those connections. Now, for most home lab setups like Prox, Mox host, self-hosted services, home servers, that sort of thing, you're probably not running IPsec, and this mitigation is completely fine to apply. The RxRPC module is used by the AFS distributed file system. Unless you're running AFS, which almost no one is in a home lab context, removing it has no practical impact. After the mitigation is applied, also clear the page cache to remove any in-memory modifications that may have occurred before you applied it with the script on screen. Again, I will try to have all of this in the video description as well. So now let's take a step back and look at what's happened over the last couple of weeks. First, we've got copyfail, which is a 9-year-old bug, and it's a universal universal root exploit with no race condition and no forensic trace, and it's now patched on most distributions. And we've got Dirty Frag, which is a different bug with the same impact found by the same researcher, published 9 days after copy fail because someone broke the embargo, and no patches exist anywhere at the time of recording this video. Both were found by the same person, both exploit the same class of page cache vulnerability, both are the result of kernel performance optimization introducing subtle logic laws that went unnoticed for years. The Hacker News thread on this has an interesting comment worth noting. One security researcher wrote that finding vulnerabilities using AI tools actually hinders creativity. When your workflow consists of asking questions and getting answers immediately, you don't get to see what's nearby. Kim found both copyfail and dirty flag through deep manual analysis of a related kernel subsystem. And the AI angle that powered copyfail's discovery doesn't apply here. This one was found the old way. And what that tells you is the page cache vulnerability class has more bugs in it. Researchers are now specifically looking for this attack surface. Dirty Pipe in 2022, Copyfail in 2026, Dirty Frag in 2026. The pattern suggests that there are more to find. Right now, the action items are simple. Apply the Dirty Frag mitigation. The command is in the description down below. Also, be sure to keep the copy-fail mitigation in place. It addresses a different vulnerability, and you still need it until your kernel is patched. Also, watch your distribution security advisories for when Dirty Frag patches ship and apply them as soon as they do. Now, as I mentioned, this story is still developing and no CVE has been assigned yet and patches are being worked on. And again, all sources will be linked in the video description. So that's a lot going on over the past couple of days. I want to thank you guys for spending a few minutes of your day with me here today. And I will try to keep you guys updated as much as I possibly can on that. But with that said, I'm going to wrap this up and I'll talk to you in the next video.